the last hour we understood to check whether the given number is prime or not. Let us summarize the same program with all the necessary header files which are required in your programming. So, you have read the value of the n, that is the number to be checked with respect to prime, by introducing the scanf statement. You are going to read it. Up to half of its number, that is if you are given 13 by 2, that is half of its number, whatever it is there, you divide with that number. If the remainder happens to be 0 for that instant, immediately you are going to say if the remainder is 0, the given number is not a prime. And you introduced one statement here, if you observe, exit 0. This is a built-in function which is available in the C language to take the control outside the program. When you introduce this statement exit 0, you should include its prototype, that is stdlib.h. This is standard libraries which are available in the C programming, just similar to stdio.h, which is required because printf and scanf statement should work. Here getch statement you are using. For this reason you require conio.h, console input output header file, and similarly you are including exit function, exit with 0. This is the status, under which status you are going outside the program. For that reason you are going to specify your exiting with 0. So, the remaining all other necessary function we have included in the program to make it, to check whether the given number is prime. So, while writing program also you maintain one similar structure. So, all the statement which starts with declaration statement, inside the loop which are all the statement to be executed, that is closed between begin and end. So, if this condition is fulfilled, all these statements should be worked. So, you should maintain some neatness over writing all these statements. Anybody can understand the programming skill easily. So, that is, practice this type of writing skill and make your program good looking, and also debugging will be easier. Let us move on to some more operators that you are available in the C language. An interesting operator that is called conditional operator. The conditional operator consists of two symbols. So, the one is the question mark symbol, another one is colon symbol. This is an interesting ternary operator available in C language. It looks like this. You will give an expression, question mark, expression 2, colon, expression 3. Here the value, whatever the expression you are going to get, if it is true, expression 2 is assigned to the variable that what you are going to assign to this statement. If this expression 1 is false, expression 3 is assigned to the value assignment. So, let us observe with one example how this conditional operator that can be used in the program. It is rarely used in our programming. You observe this statement, this is the ternary operator expression. A greater than B, this is the expression 1. Here this condition may be true or false, depends upon the values that you are going to supply. If this condition is true, A is assigned to X. If this condition is false, B is assigned to X. Example here, A is 16, B is 25, A greater than B, 16 is not greater than B, hence B is assigned to X. So, this is how you can use a ternary operator, question mark and colon. This is equivalent to if statement. If you are going to replace this instead of this expression by if, it looks like this. If A greater than B, X is equal to A, else X is equal to B. Instead of writing this 4 lines, you can write in a single line by using a ternary operator. So, this is the use of, rarely you will use it, but anywhere that there is question mark and colon operator, it is called ternary operator. It is just similar to if else statement of our programming. It is the only ternary operator C has. So, it looks like this. If condition is true, X is written, otherwise Y is written. So, this is the ternary operator support which is available in C language in order to develop the logic. So, let us observe through a program how this can be used. Int A comma b. There are two variables you are declaring. You are assigning the value a equal to 10. The value is assigned. Now observe this printf. The value of b is, here you are assigning the expression value, whatever it is, the expression computes. A equal to 1, then if a is equal to 1, it prints 20. If a is not equal to 1, it prints 30. Now since you are assigned a is equal to 10, it will not print the value of 20, it will print the value 30. Because of the statement value of b is, so it will print in the output value of b is 30. Why 30 is printed? Because this is not true. Value 30 is get printed in this position. In the same situation, another printf statement, here a equal to 10, double equal, because it is a conditional statement. If a equal to 10, here a is assigned with 10, this condition is true, hence 20 is printed on the output for this statement. This is the method of using a ternary operator in your programming in order to assign the value. This is also question mark, colon is the two symbols that are used. Let us move on to one more laboratory experiment what you are having to find out the square root of a given number. So you are all familiar with the square root function of our mathematics. So if you are given a number n is equal to 4, this is the symbol that you are going to use, square root of 4, which you are going to get 2. Square root of 25, square root of 16, its value is 4. Like that you will get its value making use of square root symbol. It is available in the calculator and where. So is it possible to develop a program? If I give the value 4, it should give the result 2. That is, you should calculate. There is a simple method which is given by Babylonian method. It is called Babylonian method, which can be used in order to calculate the square root of the number. How it works? Let us initially guess the square root of the given number and iterate to improve its accuracy until you required accuracy is obtained. So this is the method which is proposed. Initially you have to guess the value. Let us start with how this algorithm works. Read the value of n, that is the n is the number for which you are finding out the square root. Let us assign x equal to n. X is the value, that is the square root of n that you are going to calculate. Initially I will guess the number itself, its square. At each time I am dividing this number by 2, it is start getting its square root value by using the method, observe this, while x minus n by x, whatever the n value I given, divide by x, the new value that is n by x you are going to subtract from x. If the value is greater than some accuracy 0.0001 or any accuracy you require, until this condition is true, get the new value of x which is equal to whatever the previous value of x is there, for which you add n by x, the whole value you are going to divide by 2, then automatically it is reduced to half itself. So this process you are going to repeat until this subtraction of these two numbers results in 0.001 accuracy. At the end, after this loop completion, you can the condition false, control comes and print the value of x. X itself is the square root. Let us understand with one example. N, let n is the 4 for which you are finding out the square root. N equal to x equal to 4, because of the x is you are assigning to n value, you are assigning to x itself. Now the first statement, x minus n by x, 4 divided by 4 divided by 4, 4 divided by 4 is 1, 4 minus 3, it is 3, 3 is greater than 0.001, yes, hence inside the loop it will goes. So the new value of x will be x plus 4 plus n by x, that is 1, 4 plus 1 5, 5 divided by 2 results in the new value of x is 2.5. So the control goes back once again to the loop to evaluate this expression and check for the condition. 2.5, that is the new value of x, minus 4, n is same 4, divided by 2.5, 4 divided by 2.5, subtracting 2.5 from it, you will be getting the value 0.9. 0.9 is greater than 0.001, hence the new value of x is computed, which is x is 2.5 at that time, 2.5 plus n by x, that is 1.6, divide by 2, you will be getting the new value, that is 2.05. So 2.05 minus n by x, once again the control goes back and does 4 divided by 2.5. Here after the computation of this expression, we will be getting 0.098. It is greater than 0.001. Once again the control goes inside and checks the new value of x, which is 2.05 plus 1.95 divided by 2, resulting 2 value you are going to get. Now the new in the next, once again the control goes back. You observe this 2.0, that is the new value of x, minus 4, n remains same value n, 4 by 2, 4 by 2 is 2, 2.0 minus 2.0 results in 0, 0, 0, 0, 0. Is it greater than 0.001? That is the accuracy you are expecting. Since it is false, the control goes outside the loop and print the value of x. This is how an iterative statement that can be developed in order to calculate the square root of the given number. You can give x value anything, you are able to get the logic. Let us write this program and make it clear how this program can be executed in the laboratory. So here you are calculating the value of any square root of a given number, that is square root of 4, whatever the value that is going to come, that should be printed. You are having a built-in function to print this value using math.h. You are using sqrt is the function for which you are going to supply the n value. If you assign to x some variable, if you print this value, you are able to get this if you include math.h library. So is it possible to develop your own function or your own routine that what square root is doing inside, that is what the logic that you can develop. In the Babylonian method, so whatever you understood, if you convert into program, so that is include stdio.h, standard input output header file. In order to read and print, you require this file. So you require getch and all those function, for which you are going to include one more header file, that is conio.h, that is console input output header file. First you will start with main, open and close bracket, return value int. There is no semicolon here, remember this, begin, and the number that you are calculating the square root, let it be int. Let us introduce one more variable x for your purpose, for which your square root of n is assigned to the value x. First you should ask for the user to enter the value of n. Printf, enter the number for which you are calculating the value of square root. Enter the number. If you use /n, the control goes to the next line. It is waiting for until you are going to enter the value. So now you want to read that number, use scanf statement. Here the control string is %d because it is integer variable. Close this, put a comma, that is the syntax should be clear. Even a single syntax mistake results in an error, you have to debug it. So now you are reading the value of n, assign ampersand symbol to this and put a comma. Now the reading process of that number is over. So the first, let us assume the square root of n itself x, that is the initialization of x variable. Now x is having the number that whatever you read, that will be get assigned. So now you introduce our while loop, while whatever the x minus n by x. Sometime while writing the program, student you will write like this. It is bad practice because it is mathematical division statement. It is not computer statement. That is computer statement is n/x. That is n should be divided by 4. This computation is subtracted from the x value. Whatever the new value that you are going to get, if that is the accuracy that you are going to enforce. Here you can put any accuracy, 0.0001 or any accuracy that you put. This is the condition. So, if this condition is true, the new value of x you are going to get based on the formula x plus n by x, x plus n by x, the whole quantity is divided by 2. So, this is the semicolon. So, this process will repeat. It is not the end of the line that you should not put a semicolon, only this process will repeat until this condition is true, that you observe the tracing of this with an example you observed. Now, after the condition is false, the control comes out. At that moment, whatever the x value is having, that itself is the root. You print that, printf square root of n equal to percentage d is percentage d. Here you print the value of n and print the value x here. So, in the output you will get square root of 4 is 2. Here, since you are using n and x, square root will come out with a floating point. Better you convert into a floating point number, FLO it. Whenever you change to floating point number, the following are the changes that to be done, that is f is the control string, correspondingly the x and everything should be changed to control string percentage f. This is how you can change your, while printing you should not use ampersand, at the time of reading only you should use the ampersand. So, whatever the result you got, whether it is correct or wrong, that should be checked. You know the built-in function value that also gives the value. Let us introduce one more variable, say y. Y is equal to, you have the square root built-in function, square root of n assigned. So, the y will be now, you will be having the square root built-in function value, you print it, printf built-in square root of n equal to percentage f is equal to percentage f. Here you print n and y. Y is the value you are computing and the square root of that you are assigning to y. So, here the square root of n, if you compare these two values comes out to be same, this function whatever you have developed is correct, and correspondingly you can improve its performance by introducing the accuracy to some more level. So, when you introduce square root function, this all small letters. So, when you introduce this, you remember to include one more header file which is required, that is math.h. Since it is a library function which is available in mathematics library, this should be included. Otherwise, it will give error, prototype error. Prototype is missing. So, this is the error that we will get. After this, you can get ch. Until you are going to see your result on the output screen, you can introduce get ch function, return RUT or return 0, close the bracket. Here, after this execution of this statement, in order to see the new result, whatever the output result available on the screen should be washed out, you can introduce one more function at this position, that is CLR SCR, clear screen. This helps you to remove the old result available on the computer screen, the new result will be available on the screen. This is how you can develop your program, by introducing the statements that what you have learnt up to this and make your programming easier and effective. So, let us move on to some more interesting operators which are available in the C programming in order to understand. So, break statement, it is just similar to continue statement that whatever you observed in the last hour. Break is also another interesting statement. You already used this in switch statement. Switch statement, you are having this statement, it can be used to terminate a case in the case of switch statement. Switch case, after all the statement you are going to introduce one extra statement that is called break, takes the control outside the statement. This break can be used anywhere in your programming. It follows two usage. When a break statement is encountered inside a loop, the loop is immediately terminated and the program control resume at the next statement following the loop. It comes outside the loop and start executing the next statement. From the outside the loop, if you want to go out, you can also use another statement that is called break. If you are using a nested loop and all these statements where the break will be very essential statement. Let us understand with a small example. You are assigning A is equal to 10, up to 15 it should print, after the 15 you should not print the value, but you are assigned A is equal to 10, that is the initial value. If A up to less than 20, you print the values of A. So printf, the value of A is, first time it will print A. You are incrementing A plus plus. Now A becomes 11. Now we will check if A greater than 50, break. So it will not print after 15. When A becomes 15, greater than 15 means 16, the control goes outside the program and outside the loop of your while and stops your process. This is the necessity of break support in your program to take the control outside the loop. So this is the break statement, helps you in your programming. Another type of interesting operator which are available in C that we had discussed it previously, some of them are that is bitwise operator. So and single and symbol, it is used for bitwise and operator. Vertical bar symbol, that is bitwise or operator. Tilde operator, that is used for not operator, but you use 2 ampersand symbol, that is and function for a string. 2 bar symbol and exclamatory symbol, these are all the symbols you used. In order to do bitwise operation, you can use and or not symbol. Along 2 interesting symbols are there. If you observe 2 less than symbol, they are each other, and 2 greater than symbol. This is called left shift operator and this is called right shift operator. So using this operator, you can develop an interesting output which are required in our programming. Let us understand with a small example how this operator can be used. One, that is shift operator, 2 less than symbol. How it works? Let us take one variable x equal to 4. The new value of x equal to x 2 less than symbol 3 means shift this variable 3 times. This is 3 refers to how many times you want to shift it. The working principle is like that. Whenever you take any number, it is stored in the computer in the binary fashion. You are familiar, this is LSB bit and this is the MSB bit. 4 is represented as 0, 0, 0, 0, 0. In the 4th position, that is 2 to the power, this position will be bit will be 1, 0, 0. This is the representation in the binary number. When you assign x is equal to 4, it looks inside the system in the binary fashion. When you shift left, all this bit will be shifted once left. This bit will come to this position, this bit will comes to this position, your 1 now shifted to this. So in the first shift, your value 4 now becomes 8. When you shift once again, because here you given 3 times you shift that number, this 1 bit will come to this position, its value now becomes 16. If you shift once again, it becomes 32. Now if you observe this, your 4 is now become 32. So as good as it is multiplying by 2. So this is, so 4, 8 is the first shift, 16, 16 2s are 32 is as good as multiplying towards left side. If you are shifting, the number is multiplying by 2. So this is the operator support of left. Let us use right shift. How it works? Take a number x is equal to 96. If you want a 96 means 64 plus 32, 96. That is 110000. It is the binary representation of 96. That what you are understood. What is the binary form of representing a decimal number? When you shift right, this one move to the next position. This one is moved to next position. It looks like 0 1 1 0 0 0. Here your value is now becomes 32 plus 16, that is 48. When you second shift, its value become 0 0 1 1, this value shifted to right. Once again third shift, it becomes 12. if you observe, the number is divided by 2. 96 when it is divided 3 times, resulting you are able to get 12. So it is as good as dividing by 2 is the outcome of this right shift operator support. Using this operator, develop a program so that when the usage will be clear. So while doing, you observe this int, similar to program, a and b, 2 variables you are declaring. Same a you are assigning 98, next 96 you take, b equal to 4. Here 98 I have typed, it is 96 because in the previous example support you have observed 96, b equal to 4, a equal to a, 2 right side symbol 3, resulting a shifted 3 times and b shifted left, that is 3 times. So when you print the values of a and b after these two operations, the result whatever you got 12, 32, that can be observed here. The value of a is printed in this printf statement, %d a, b is printed in position. So this is how we can use the variables a and b with the help of support. Here the value is 96. So another interesting support which is available in the C programming is the typecasting. So nothing but you are, up to now you used some variable as int, some of the variables as float in your programming. So you require this integer variable to be converted into float, and float variable should be converted into integer. So this type of situations which are required in your program. So how to develop routines which are required to change the data type, that's why it is called as typecasting, changing the type of the variable declaration which you have done previously in your declaration statement to another data type. It is a process of converting an expression of a given type to another type, that is called typecasting. If you are given int as the type, you can convert into float. If you are given float, you can also convert to integer. Like that you can change. When two operands in an expressions are different, it will do mixed mode operation, resulting the value that what you are going to get properly assigned to your LHS symbol. So user explicitly changes this data type by using type conversion support. So this support can be done like this. So observe this, int a is equal to 3. The value of a is integer variable, it is 3. Float b is equal to 0.0, that is b are assigning 0.0, this is the initial value. Now you have an expression in your programming, b equal to 1 divided by a. You are expecting the 0.33 to be outputted, but you will not get your output as 0.33, you will get your output as 0.0. What is the reason? Because you are assigning one, a is integer, 1 by 3, 1 is also integer, 3 is also integer. So integer division will do 0.33, it will give only the left part of decimal part will be truncated, 0 will be assigned to b, hence the b value will be printed as b is equal to %f, it will print it as 0.0 and the b will not be properly printed. How to get its value? Using this program only you can get its value by changing the type of a to float. This can be done like this, b equal to 1 divided by inside the bracket whichever a is integer, now you want the float of its value, float. Now the value of a instead of 3 it becomes 3.0, 1 divided by 3.0 mixed mode operation. This is one integer, another one is float, the result will be float value, that is 0.333, that will be assigned to b. When you print b value now, you will get the output as 0.333. So this is the support of changing the data type from one domain to another domain. So if you want integer, if the variable is float, you want integer, only change your int. So this is the support of typecasting or changing from one domain to another domain. So this is the support of typecasting. There are other special operators which are available, that is called comma operator. Now we understood so many operators, arithmetic operator, relational operator, logical operators, Like that, you are introducing one more special operator, that is called comma operator. This operator combines multiple expression into single expression. So if you observe this, there are a is equal to 4, comma b is equal to 5, c is equal to 2, comma c is equal to a star b, and assigned to x variable. There are 4 expressions you are combining in a single expression, that is combining the multiple expression into a single expression. These expressions are separated by a comma. That is why this operator is called comma operator. The value of the rightmost expression is assigned to the left expression. The rightmost expression here, it is the last one, that is get assigned to a. What is the value of x after this expression? A is equal to 4, 4 is taken here, 4 is get multiplied with b, and then it is added to c. So resulting, because hierarchy of expression, a star b will be done first, 4 into 5, that is 20, 20 is added to 2, resulting 22 is get assigned to x. This is how we can use a comma operator in your support in order to combine more than one expression to form a single expression. That is called a special operator, which is available in C language. Another interesting operator is the size of operator. Size of, the usage is SIZE-OF. This is a single function, there is no space here. Size of, just similar to square root, sine, or like that, how you are going to use. There is another interesting operator, that is size of. Inside the bracket, you are going to specify to which operator you are getting its value. So now you observe there are different data types you use it in your program. It may be character, integer type, floating type. So it is used to determine the size of the operand based on its data type. For example, float r equal to 12.45. You are assigning 12.45, that is the value, to a variable r which is of type float. Float inside the memory location occupies 4 bytes. So how this size of function can be used in your programming is y equal to size of r. So what size of r refers to, since r is a float, the value y is now become 4. So 4 bytes that will be taken. If the variable is int type, when you use size of the corresponding int type variable, then it prints 2, because 2 bytes it occupies. So the size of function supports in the programming, while using it gives how much memory location the size occupies by this variable inside the memory location is printed. These are all some of the rarely using operator in our programming. So these are all varieties of things. Up to now you understood to print your variable or whatever the output you are going to get in its own fashion, by default fashion the output will be you are getting. So if you want your output to be printed in a well formatted way, so what is to be done? I think in your programming, while doing your programming in find out the roots of quadratic equation, you used r1 is equal to minus b plus square root of b square, or discriminant divided by, whole thing is divided by 2 into a. That is the expression you used in order to calculate the roots of quadratic equation. While printing, you have done like this: printf root equal to percentage f r1. When you print this value in the output, you are going to get some number, say example 2.34444, like that you are going to get your output, some number that you are going to get. So it looks odd. You want to print your output in the required fashion. I want the output to be rounded to 2 decimal point. You want output 2.34 you require, or you want 3 digits, it should be printed up to this position 344. Above this your 5 and its above, it should be, previous number should be incremented by 1. So this is how you are expecting your result to be printed on the output. This type of printing logic is formatted. The way in which you want your output. That is why it is called formatted output statement. How to get this formatted output in the in your printf statement? A simple support is there in the programming. So let us take this example, a equal to 14, that is integer variable. So if int a is assigned with 14, now you use in your programming printf %d, because this is a control string, you are familiar. When you print a, in the output you will get 14. You want this to be occupies only 4 columns. If you use here 4 refers to how many columns that should be occupied, that is 4, that is the width. D, if you specify the same thing, in the output you will get 2 blanks and then 14. Here B stands for blanks. If you specify like this W.3 4.3 D, then only 3 columns it occupies, but 14 is only 2 numbers. 0 is added, padded here. In the output you will get blank, that is it will not be displayed. 0, 1, 4 you are going to get in the output, because you are specifying how many columns this number a should be printed. Since value is only 14, 2 columns, you are forcing to get 3 columns output. In the output it will print 0, 1, 4, it will not change value, but 0 is padded to the left side. So that is, you want from the left shifting, from the left side it should be start, you want to print. A simple support is there, percentage. Here you will use one symbol that is called -4, 4 columns D. In the output you will get 14 BB, blank it is 14. Here right shifting support and here left shifting support. You want, if the same thing it is done -4.3, this change is minus here. Here there is no sign anything as such. Minus, it is not a negative meaning, it is the supporting to print the variable from the left justified. In the output you will get 0, 1, 4, this is blank. So this here B stands for blank. This is the support that can be taken in order to get your output in the formatted way. So same thing that you required for floating point number. So in the floating point number, float a equal to 10.437, that is the value you are assigning to this. When you print the same variable in the output, printf %f a, you will get 10.437000, that will be get padded, and totally you are going to get almost 6 digit after the decimal point by default, depends on the compiler. Anyway, this is, you don't want this output to be printed like this. I want only 2 digit to be printed, 10.43. Because next number is greater than 5, this should be printed as 10.44. So in this way you want to restrict the number of digit after the decimal point. You have a support in the printf %w.d, here refers to, it is not, it is control string. W here refers to number of columns for integer part, that is what your number of columns are required. D refer to number of digits to be limited after the decimal point. You want 2 digit to be limited or 3 digit to be limited, here you are going to specify the number. Here 4 number of columns of integer part that is to be printed. The same example A, when you want to print, instead of using %f only, you attach %4.2f, double quote, put comma, then in the output we will get 10.44. It is because after this number, whatever it is greater than 5, it will be taken the next value 4. If this value is say 2, 4.32 is assigned, then it will print 10.43 only. So this is how you can best utilize the formatted way of printing your output by taking the support of W.D, that is the support of width and as well as decimal point. So make use of this in all your programming to look your output very clean, especially in the case of roots of quadratic equation. Now you have printed by default. So you want to restrict your output to a required number, introduce these two facilities in your printf statement to make it more accurate and effective. So in all your program you used getch up to now, getch. In order to see your result, until a character is pressed, your result will be displayed. It is available in one of the header file that is called conio.h. Like similar to getch, you are having other two function. One is getchar function, getche function. So in the examination they usually ask what is the difference between getchar, getche and getch. All are to read a character from the keyboard only, come from the console. To read from the console through the keyboard support, you are going to read a character. How this works? Getch work you are familiar. It is used to get a character from the console. It does not echo onto the screen. It will not display what character you have pressed. But whereas in the getchar function, if you use it to read a single character at runtime means execution time, value is displayed on the screen and the compiler waits for another character to be typed. So that is getchar function working principle. If R is getche is used, the small change it is used to get a character from the console and echoes to the screen. And as well as the given value is displayed on the screen and the compiler does not wait for another character to be typed. So that is how a getche function works in the programming. You can use this function in your program in order to develop the logic. So how to use this function? Observe this simple program. char, ch, that is ch is a variable of type character. In all our program up to now you used only int float. So character is also another type which is available in the C data type. You can assign any variable of type character, means you can take only single character. Getchar is the function assigning to the variable ch. Whatever you typed on the screen, that will be get assigned to this variable. Putchar is the function print that whatever you have taken from the console and it will be printed onto the output screen. So just this output you can observe until you press a character in the keyboard. So like that you can use getche, getchar, getch function in your program wherever it is required in your programming. Up to now you have introduced only three data types, that is int, float, character. So using this you have developed our logic. So how to take your name anywhere, that is comes under next chapter, that is on string handling function. String means group of character. How to read a name, how to read your register number which is consist both number and as well as alphabet. So how to read such type of data in your programming. So you require an interesting array support, and here name inside the square bracket you are going to specify how many characters are to be read for the variable name which is of type character. Anywhere this type of support we are going to understand in depth in the next programming. To read a name you can use enter a name, that is printf statement. So there is a function called just similar to scanf, read a printf statement. You are having one function called getas, get a string name. What is a name? Name is a type of variable character. Up to 10 characters you can read to this variable name. Get as your name, whatever you type, that will be taken to this variable. The taken data you want to print onto the output screen, you can use puts function. It is similar to printf. Here instead of using control string percentages, you can make use of puts function to print onto the output screen. So this is how you can use getas and puts, an interesting function available in the C language in order to read group of character or a name. So the more usage of this function you can observe in the next chapter on strings chapter. So up to now you understood so many different types of in the module 1 and 2. The various questions that can be comes in your examination, and you can way which you can answer is that almost all the necessary things which have been given. So some interesting question: what is a variable and a constant? List the rules to be followed while declaring a variable. A variable is a quantity whose value is going to change during the execution. A constant is a quantity whose value remains same in the programming or execution. That is how you define these two interesting words. Another is how to declare a variable. Up to now I declare variable A, B, C, like how to declare that variable. The first character should be alphabet. From the second character onwards it may be alphabet or a digit. Only a special character underscore is allowed. These are 3 or 4 rules that should be clearly written, and you should specify the example for it. 1 or 2 example, valid and invalid. That is how you can get answer this question effectively. Another interesting question usually you can observe is, what are data types? List the data types available in C programming language. Up to now you understood integer data type, float type, character type, and using this you are going to derive other type of data types, arrays, structure. All these are all derived support that you can understand in the coming classes. Anywhere up to now you can answer data type, a variable that can hold particular type of data. That is what the data type means. So it may be an integer type, or it may be floating type, character type. And another interesting question that you can always list and explain with appropriate examples the various operators used in C language. So you used so many operators now, you are familiar now. That is, it may be arithmetic operator, plus, minus, star, slash, percentage symbol, that is called modulus. They are all comes under the arithmetic operations. And along with this you have understood relational operator. They are less than or equal to, greater than, equal to. Here equal to is double equal to symbol, and not equal to. All these operator comes under the relational. Other operator you have understood is logical. That is 2 ampersand symbol, vertical bar symbol, and as well as not symbol. So that is, you can also use bitwise operator, single operand. That is what you understood today. That is bitwise operator and or not. How to use this bit operator in the programming? It is simple to use the single bit operator in the programming. So let us understand with a small example how we can use the bit operator. So main int or void, whatever it is there, begin int A, B, C. Let us take one variable. A is assigned with 4, B is assigned with 8. Let us say C is equal to A and B. What is the value of C? It is single bit operator. You observe this single bit. So you are familiar with binary representation of A4, that is 0 0 0 0 1 0 0. This is 1 2 4 8 position. This bit position will be 1 because A is 4. This is the value of A. Similarly, B is equal to 8 means 0 0 0 1 0 0. When you do logical operation of this bitwise AND, that is A and B, so logical of 0 0 output is 0, 0 0 0, 1 0 is also output is 0, 0 1 0. So output, if you print the value of C, you will get the value 0 on the output. How to use logical operator? Let us introduce one more variable, say D. D equal to A or B. So this is the OR operator, vertical symbol. So when you use this D value, when you do these two logically OR, the output will be 0 0. Here 0 1, output is 1, 1 0 1 0 0. That is 8 plus, this is position is 8, this is 4. You will be getting 12 for D, 0 for C. So if you print these two values using printf statement, you can observe the result on the screen, that is C equal to %D slash T, that is to move to 8 blank spaces, then D equal to %D, and you print the value of C and D, that is value of C to be printed in this position, D to be printed in this position, put a close and get ch, end of your program with return statement, return 0 semicolon. If you do not use semicolon, you will get an error in the output, semicolon is missing. Appropriately you place the semicolon if you have forgotten to place it in your at the time of execution. When you run this program, you will get the C value will be printed as C equal to 0, and after tab you will get D equal to 12. That is the output you can use it. So this is how we can use a bit operators available in the C programming. So like that, another interesting question that usually comes is compare while loop with the do while statement. You understood, you can also replace the program written in while loop in do while loop also. What is that, how to compare these two? First one is, in the while loop we will check the condition first, and then if the condition is true, the control goes inside the loop. Whereas in the do while, even the condition is false initially, the control goes inside the loop and start execute one time. Condition will be checked at the end. That's why it is called exit control. Whereas this statement is called entry control. Before going to the loop, it will be checked and then it will be sent. This is the main difference between these two. With differences are 3 or 4 points, narrate it and develop a logic comparing of these two important statement, control statement available in the C programming. So like that, you can also develop so many programming simple example. Write a program to exchange two variables or the two numbers. You will give one variable, say A is equal to 10. B is equal to 20. I want to exchange the value of B to A and A to B. That is called swapping these two variables. If you assign A equal to B, the value of B will be value of A will be lost. If you use this statement, B is equal to A, now the value of B is also 20, A is also 20. Instead of this, a simple logic that can be introduced. Let us introduce one temporary variable, say T or temp or any variable. First you assign T equal to A. That is, A value you are moving into the chair. You want to exchange two persons sitting on the chair. We will put one more chair, let the first person sit in the new chair and second person sit in the first chair, and this person will be goes to that position. That logic that can be used. First A is assigned to T. Next, the value of B, whatever it is there, that is get assigned to A. Now in the T variable, original value of A is present, that point that can be assigned to B. So in this way, using these three statements, it is possible to swap two. Before this, you print the value of A, afterwards you print the value of AB. You can observe the value of B goes to A and A goes. Like that, you can develop very simple logics while writing the program, and you have already checked the given number is prime or not. Now this is an interesting program that will be asked. Generate Fibonacci series, that is 1 1 2. If you observe this series, 1 1 is added, previous two number added, and you will be getting next number. Previous two number is added, next number. 3 plus 2 5, 5 plus 3 8, that will continue. This type of logic is called assign to these two a single variable. A is equal to 1, B is equal to 1, C is equal to A plus B. Like that you can generate. Use this logic in order to swap this and continue your iteration until you are going to reach your function. So in this way, you can develop a logic for a Fibonacci series. While writing a program, you can observe so many different types of error that will be encountered. Some of the errors that you are familiar with: prototype error, missing of the prototype, semicolon is missing, comma is missing, variable is not defined. If you are going to use variable here, you are not declared here, then you have to declare this variable. If you do not put a comma, comma is missing. Written this, if you are not placed semicolon, semicolon is missing. Similarly, if you have not given the end of the statement, then end is the flower bracket is missing. Like that, you can find numerous type of errors that will be encountered while typing the program. Correct one by one slowly, you are able to understand the correction of this error. That is called debugging your program. Bug scene means the error, you are removing that error, that is called bugging of your program. Like that, you develop your programming skill in all these things and take your writing skill of programming with logical meaning. With logical support, you can make the programming very attractive and more effective. So with this, let us end the module 1 and 2. Thank you and best wishes.